Today we will be talking about indium tin oxide transparent conductors. Due to the unique properties of this class of materials, they have a large potential in numerous industries. Most prominent is digital display. Now hold on and brace yourself for learning.
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy.
Indium tin oxide, or I.T.O., is the most commonly used transparent conductor. It can be up to 90.2% transparent, while maintaining a conductivity of 7.2 × 10⁻⁴ ohms per centimeter. This pairing of conductivity and transparency is extremely rare. The material needs to have a band gap just large enough that visible light can pass through, but narrow enough where it can still be conductive. I.T.O. can be applied to glass, silicon, germanium and polymer substrates. The application process is known as deposition. We will be discussing methods of deposition, as well as laser lithography used to etch conductive pathways. Finally, we will go over the uses of transparent conductors. In spray pyrolysis, the source material is sprayed in liquid form onto a heated substrate. A chemical reaction occurs which causes the formation of a thin film. This method is different than the others mentioned as it involves a chemical reaction, and that the source of the thin film atoms is a liquid rather than a vapor. Thermal evaporation is a physical vapor deposition method in which the source material is heated in order to cause evaporation. One method for heating is through an electron beam. Evaporated particles from the source travel to the substrate, where they condense to form the thin film layer. This process occurs in a vacuum in order to minimize collisions between the source particles and any background gas, as these collisions can result in reactions, which decreases the amount of source that reaches the substrate, which would make thickness difficult to control. Uniformity can sometimes be difficult to control due to the fact that the source particles are deposited from one direction only. Sputtering involves the removal of particles from the source through bombardment of high-energy particles, usually from a plasma or an ion source. Shown is an example of magnetron sputtering, in which a closed magnetic field traps electrons to generate the plasma used for sputtering. One advantage of this method is that it allows for plasma formation at lower temperatures, reducing the presence of background gas which would cause inconsistencies in film thickness and uniformity. Laser lithography is an etching or scribing technique which uses a laser to remove a thin film layer from the surface of a material. This process is used to remove the deposited layer of I.T.O. on a material in order to create a functional circuit, using the remaining conductive oxide to guide electrical signals. I.T.O. transparent conductors are used in commercial aircraft windscreens. The transparent I.T.O. windshield coating creates a thermal electrode that is used for de-icing. It can also be used for military aircraft canopies. The translucent canopy coating creates a radar dispersing surface useful for stealth. solar panels use translucent electrodes etched onto photovoltaic cells in order to convey current without obstructing transmission of sunlight. Activated by charge from human skin, ITO etched layer is sandwiched between a digitizer and a screen in a phone or tablet. A clear electrode grid arrangement provides an electrically sensitive interface.
Capacitive screens do not use the pressure of your finger to create change in the flow of electricity. Instead, they work with anything that holds an electric charge, including human skin. Capacitive touchscreens are constructed using materials like copper or indium tin oxide that store electric charges in an electrostatic grid of tiny wires, each smaller than a human hair.
The future is bright for transparent conductors, but ITO may be finding itself on the way out. Indium is very rare. Only 0.000016% of the Earth's crust is made up of this material. It has a market value of roughly $900 per kilogram. This graph shows the projected growth of non-ITO displays over the next several years. The values are reported in millions of dollars. When ITO is factored into the growth, the numbers are projected to increase as well, but not to the same degree. The majority of revenue will be from flat panel displays, as shown by the blue bars.